Hello children, today we'll be solving miscellaneous exercise of your chapter 7, that is permutations and combinations. In this we have 11 sums, so let's solve these sums one by one. First question is, how many words with or without meaning each of 2 vowels and 3 consonants can be formed from the letters of the word daughter? So let's check. We have D as a consonant, A as vowel, U is a vowel, G is a consonant, H, T, they are consonants. We are keeping vowels on one side and consonants on other side. So you can see we have 3 vowels and 5 consonants, and out of which we have to take 2 vowels. Okay, pronunciation I don't know, vowels or vowels, anything you can understand. Okay, so out of 3 we need to take 2 vowels, so can be taken in 3C2 ways. And out of 5 consonants we need 3 consonants that can be taken in 5C3 ways. But these 2 vowels and 3 consonants, they themselves can be arranged in how many ways? 2 plus 3, that is 5 factorial ways. So this is the total number of ways. 3C2 is 3 factorial over 3 minus 2 factorial, that is 1 factorial, into this 2. 5 factorial, 5 minus 3, 2 factorial, into 3 factorial. This is 5 factorial as it is. 3 factorial got cancelled. This is 5 factorial is 120 into 120 over 2 into 2, 4. If we cancel this, we get 30, and 30 into 120 is 3600. That's your answer. Second question is, how many words with or without meaning can be formed using all the letters of the word equation at a time so that the vowels and consonants occur together? Again, writing vowels and consonants separately. E, Q, U, A, T, I, O, N. So we have 5 vowels and 3 consonants. Can be written in form or in ways, 5 factorial ways, and these 3 consonants can be written in 3 factorial ways, and they should occur together. So these places they can interchange, so that is it can be done in 2 factorial ways. So this is the total number of ways. Now the words can be written. So solving this is 120, 3 factorial is 6, 2 factorial is 2. So 12 into 12, 144, and 0 is there. So this is your answer. A committee of 7 has to be formed from 9 boys and 4 girls. In how many ways can this be done when the committee consists of exactly 3 girls, at least 3 girls, at most 3 girls? Okay. So first case is exactly 3 girls. That means girls 3, but total we need it to be 7. So boys will be equal to 4. So total we have 9 boys. So out of 9 boys we need 4. That is 9C4. Into out of 4 girls we need 3 girls in 4C3 ways. So let's calculate. 9 factorial over 5 factorial 4 factorial, into 4 factorial, 1 factorial, 3 factorial. This can be cancelled. Let's solve this. 9, 8, 7, 6, 5 factorial, 3 factorial is 6, cancelling this. 9, 8, 72 into 7, 504. So these are the total number of committees with exactly 3 girls. Second part, at least 3 girls. So there can be sub cases, at least 3 girls. First is girls 3, so naturally boys will be equal to 4 because total we need equal to 7. B is girls 4, naturally then boys will be 3 because total we need 7. Can girls be 5? No, because total we have 4 girls, we cannot have 5 girls. This A part can be done in how many ways? That is 3 girls. Out of 4 we need 3 girls, and out of 9 boys we need 4 boys. B part is 4 girls out of 4 and 3 boys out of 9. Okay, so we need to find this because this is this, or means addition. So this is 4 factorial, 4 minus 3, 1 factorial, 3 factorial, 9 factorial, 5 factorial, 4 factorial plus. This is generally 1, this is 4, but I'm solving it completely so that you can understand better. Okay, this 4 can be cancelled. This is 9 factorial, we can take common also. Okay, let's solve this. 9, 8, 7, 6, 5 factorial over 5 factorial. This is 3 factorial, that is 6. Plus 9, 8, 7, 6 factorial over 6 factorial into this 6. Okay, 5 factorial cancelled, this 6 cancelled, this 6 factorial cancelled, this 6 can be cancelled with this 9, we get 3 because we have divided by 3. Now this 2 can be cancelled with this 8. We get 4. So this is equal to 987. I think it is same, 504, and this is 84. So total is 588. Third part is at most 3 girls. So subparts are girls 3, boys will be 4, or B part is girls 2, boys 5, girls 1, boys 6. Yes, boys can be 6 because there are 9 boys. And D, girls 0 and all the boys, that is 7 boys. So this can be done in 4C3 plus, into 9C4, B part plus, because this is all the OR subparts, 4C2 into 9C5 plus 4C1 into 9C6, 4C0 into 9C7, and after solving this we'll get 1632 as your answer. Fourth question is, if the different permutations of all the letter of the word examination are listed as in a dictionary, how many words are there in this list before the first word starting with E? So as we can see, before E there is a letter A which is there in the English alphabet and also in the dictionary. So we'll find all the words which are starting with letter A. So if we take this A and the rest of the letters toward this side, E, X, A, M, I, N, A we have written, one A already we have written here, T, I again, O, N again. So we have, if A by keeping this A fixed, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. So they can be arranged in 10 factorial. Any repetition? Yes. I is there 2 times and N is also there 2 times. So we'll divide this. So this will be the different permutations of all the letters of the word examination which are there in the dictionary before the word starting with E. Fifth question is, how many 6-digit numbers can be formed from the digits 0, 1, 3, 5, 7 and 9 which are divisible by 10 and no digit is repeating? So as we know, any number is divisible by 10 if it ends with 0. So the last digit should be 0. And we need 6-digit number. So we need here 1, 2, 3, 4, 5 because 6th one will be this 0. The first position can be occupied by any of these numbers 1, 2, 3, 4, 5 in 5 ways. And no digit is repeating, so that's why for the second time we will be left with 4 numbers, then 3, then 2, then 1. This is fixed one. So therefore the number of 6-digit numbers that can be divisible by 10 will be 5 into 4 into 3 into 2 into 1, that is 120. That's your answer. Sixth question is, the English alphabet has 5 vowels and 21 consonants. How many words with 2 different vowels and 2 different consonants can be formed from the alphabet? So vowels or vowels, as I said again, just try to understand the this concept. Consonants 21. We need 2 different vowels, can be done in 5C2 ways, and 2 different consonants out of 21 C2 ways, and total number of words we need. Now just see, 2 vowels and 2 consonants are there, they themselves can be arranged. Okay, in how many ways? This can be here, plus can be here. Okay, plus means consonant I have taken over here to just make you understand. So they can themselves be arranged in 4 factorial ways. So total number of words are these. I can calculate this. That is 5 factorial over 5 minus 2, 3 factorial, 2 factorial, 21 factorial, minus 2, this is 19, 2, and this is 4 factorial. Okay, let us try to calculate this. This is 3, 2 factorial is 2, 21 into 20 into 19 factorial. This is 2, this is 4 into 3 into 2, that is 24. Now this can be cancelled. At 2, this also can be cancelled. We get 10 over here. So this is 10 into 10, 100. 21 into 24 we can calculate. That is 504. So total we got 50400. That's your seventh question. Is in an examination, a question paper consists of 12 questions divided into two parts, that is part 1 and part 2, containing 5 and 7 questions respectively. Okay, a student is required to attempt 8 questions in all, selecting at least 3 from each part. In how many ways can a student select the question? Okay, there are 2 parts. Total 12 questions containing 5 in one and 7 in the second, and a student is required to attempt 8 questions. Okay, 3 at least from each part. So there are subparts like 3 questions from first part, then total we need 8, so 5 questions from second part, or 4 questions from first part, 4 from second part, or 5 questions from first part, 3 questions from second part. So these are the possibilities which can be done in, from 5 we need 3 questions to choose in 5C 3 ways. Out of 7 we need 5, so 7C 5 ways. Similarly, this is 5C 4, and this can be chosen from 7 in 7C 4 ways. 5C 5, 7C 3. So total number of ways we can add them. So 5C 3 into 7C 5 plus 5C 4, 7C 4, 5C 5, 7C 3. After solving this, we'll get 420 ways are there to solve questions. Eighth question is, determine the number of 5 card combinations out of a deck of 52 cards if each selection of 5 cards has exactly 1 king. So we know the number of kings are there in a deck of cards equal to 4, and non-king will be 48 because total we have 52 cards. Now we need number of 5 card combinations, and each selection of these 5 cards have exactly 1 king. So this can be done in, 1 king can be selected out of these 4 in 4C 1 ways, and rest of the 4 cards can be selected from non-king, that is out of 48 cards. So this can be done in 4C 1 into 48C 4 ways. This is your answer. You can solve it. Ninth question is, it is required to seat 5 men and 4 women in a row so that the women occupy the even places. How many such arrangements are possible? So let's first make this 5 men sit. Can be done in 5 factorial ways. This is first man, second man, third man, fourth and fifth man. So this total can be done in 5 factorial ways. So I write here number of ways 5 men can sit is equal to 5 factorial ways, and these women have to sit on even places, that is the second place, fourth, sixth and eighth place. So there are 4 places and 4 women are there. So number of ways four women can sit at even places is equal to 4 factorial ways, and total arrangements equal to 5 factorial into 4 factorial, that is 120 into this is 24. So can calculate this. 24 to 48, 4 carry, 28. 2880 is your answer. 10th question is, from a class of 25 students, 10 are to be chosen for an excursion party. There are 3 students who decide that either all of them will join or none of them will join. In how many ways can the excursion party be chosen? Okay, so there are 2 cases. Case 1 we write when these 3 students will join. Okay, and case 2, 3 students will not join. Okay, let's understand this. If they join, then 3 have already there. So out of 25, how many left to be selected? 22, because 3 have already chosen. 10 are to be chosen. So 3 already we have chosen. So how many left? 7. So total number of ways will be 22C7. I explain this here also. 25 are total. And to choose or to be chosen, we need 10. When 3 students will join, they are already there. Okay, so 3 we have already chosen. So how many are required? 7. When 3 are already chosen, so how many total left? 22. So 22C7. Second case is 3 students will not join. So total 25, to be chosen 10. They will not join. So this to be chosen require the same quantity, that 10 we have to choose. But we don't have now these 3 students because they are not going to join this. So we are left total with 22 and we have to choose all the 10 students. So can be done in 20C 10 ways. So total ways 22C7 plus 22C10. Can calculate if you want. 11th question is, in how many ways can the letters of the word assassination be arranged so that all the S are together? We write A, this S, A, then S, and this S, then I, N, A, T, I, O, N. So this we need all together. So we assume it as one unit. So we are having how many elements? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So assuming it as one unit, we total have now 10 units. So can be done in 10 factorial. Over these 3 are repeating. These 2 I are repeating. 2 N are repeating. Now these 4 S, they themselves can arrange in how many ways? The 4 are repeating. So 4 factorial over 4 factorial. So solving this, we can cancel this, and this is equal to 15120. That's your